Fortunately, that Florence also has the Italian National Library, where we're now sitting. And of course, this happens to have the greatest collection of rare manuscripts from the period of Italian history in the world. And it's got a very complete collection of the many notebooks that Galileo kept when he was observing with his telescope. So we can actually see what he was doing when he first started looking at the sky with his telescope in 1609. And it apparently came as a pretty big surprise to him as to how much he could see with the telescope. As I mentioned before, he was just about the first kid on the block to order his own telescope, and as far as we know, just about the first person to think about actually using it to look at the heavens, as opposed to spying on neighbors, using it for military exercises or things like that. And what he saw really blew him away. In fact, he was so knocked out with his telescope observations that he ran off after just a few months of having the new telescope and published his new observations in an interesting book called The Starry Messenger. At the Biblioteca Nazionale, we happen to have a first edition copy of The Starry Messenger, right here, which was published down the road from Padua in Venice. There's the front piece for it, very nice and elaborate. But what I actually think is more interesting is to look at the observing notebooks that Galileo recorded at the manuscript here. We're in the rare manuscripts room. And this is a diagram that Galileo has made showing the basic principle of his telescope. Remember, he didn't invent it, but he understood how it worked. It's really very simple. He just uses a combination of two polished lenses, two pieces of glass, separated at different ends of the tube, and it was realized that this made the light converge from a distant object, making it appear closer. And so that's what the principle of the telescope was. Now, one of the first things, certainly, that he must have looked at with his new telescope, a very small, tiny telescope by modern standards, was the moon, the most interesting object in the sky after the sun in terms of brightness. And when he looked at the moon, of course, he saw fantastic detail that people had not realized before. Get to the right page here. And so here are some of his hand drawings. I must say I'm very impressed by the artistic quality. I think that Galileo was a very fine draftsman. Of course, this was an age when the distinction between an artist and a scientist hadn't been made yet. That was a nice time, and maybe he was a little bit of an artist as well as a great scientist. The reason that I'm very impressed by these drawings is that if you look closely, you can see, as Galileo was able to see, quite a few craters, especially where the shadow of the sun is running out here, the terminator along the moon. It shows a lot of relief, and you can see a series of mountain ranges also. Now these craters, some of them are actually identifiable now from our very detailed maps of the moon, so it just confirms that he was a very sharp observer, and his telescope worked pretty well. And of course, by looking at the moon in different phases, he was able to get a nice contrast with a lot of shadows on different parts of the lunar surface, that is, the half of the moon that faces us. And so there's even a little drawing on the back side of this, which is kind of cute. This one over here with the star close to the moon. And anybody knows what this drawing is down here, or wants to know, you'll have to ask me, because it's a little bit embarrassing. Second thing, stop. A close-up pan of Galileo's drawings of different phases of the moon. You can see a not a very steady shot here. And you can see the big crater that was later called Tycho over there. And then there's a nice shot of a quarter moon. Hope that comes in focus reasonably well. Anyway, so that you can appreciate that these are really pretty good drawings, particularly considering the small size of the telescope that Galileo had to work with. Of course, aside from making very pretty drawings of details of the moon that nobody had ever seen before, Galileo realized that this had a lot of implications. For one thing, he realized that the classical Greek idea of a base Earth and perfect crystalline heavens was wrong, because he was looking at the heavens here, and instead of being a crystalline perfect sphere, the moon had all kinds of irregularities, craters, and mountains. In fact, it really looked like an Earth-like world. It had terrain, mountains, and things, and Galileo realized this was another world that he was looking at. It was not a heavenly, perfect crystalline sphere, completely different from things that he was familiar with on the Earth. That was a very important discovery because it already knocked out one of the key assumptions or the key props of the geocentric theory, because it really all went back to these ideas that the Greeks had put forward more than 1,000 years ago that hadn't really been challenged with any observations in all that time. So that was one of his first observations. Now, he soon pointed his telescope at something that turned out to be even more important, which was Jupiter. And almost as soon as he looked at Jupiter, first of all, he realized that it didn't look like a star because it was a noticeable disk, or there was a noticeable round object there that he could actually see the size of it, unlike stars. But even more surprising, he saw something nobody else had seen before. He saw that Jupiter always seemed to be accompanied by 4 rather bright, well, he called them stars, which were in a line very near Jupiter. And here is one of his first drawings of what he saw through his telescope of Jupiter, right here. Let's see if we can figure this out. Genio, January 1610, what is this, the 7th of January, and he's looking at Jupiter here. There's the symbol for Jupiter, and then you can see he's drawn these stars. Sometimes they're all on one side of Jupiter, sometimes they're on the other side, sometimes one of the stars is behind Jupiter or in front of it. After a number of days, he had a lot of clear weather here. I kind of admire, I'd say envy, his luck in observing one clear night after another, and he was pretty dedicated. He was out there drawing these stars around Jupiter every night. So eventually he realized that all 4 of these little stars were moving around continually because they were going around Jupiter. They're satellites that are in orbit around Jupiter. Now, he didn't realize, he didn't have enough magnification to realize that these are actually moons of Jupiter. They're not stars. Anyway, he called them stars. They're now known as the Galilean satellites because he discovered these 4 moons of Jupiter. But remember, he was always looking for a better job, and so he gave them a very clever name. He called them the Medici stars of Jupiter. So he was naming them after the most powerful and wealthy patron of the arts and sciences in Italy at the time, and he was really hoping to get a job with the Medici in Florence. I don't think that actually worked out, and so the name didn't stick. But that's it for now. Let's cut for now. Are the woodblock prints that Galileo did for his book, The Starry Messenger, and things that came out pretty well here. You can see a number of craters from his original drawings. Pretty realistic looking, actually. I don't know too many astronomers today who could do such a good job. Look at these in another phase as well. Something else very interesting that's published in this book, which we'll discuss more in Astronomy 2B, when he turned his telescope to the Milky Way, he was the first person to realize, now this is a reproduction of the drawing from his original notes here, that what actually, without a telescope, just looks like a milky patch of light across the sky, across our summer sky, is in fact actually the light of thousands of individual stars. Many, many more stars than anybody had ever imagined could possibly exist. But his telescope revealed that. That, in some ways, is one of his most important discoveries for the long term, as we'll see later in Astronomy 2B. This is a very nice drawing of the Pleiades, where he realized that there were dozens more stars than anybody could see in the Pleiades with the naked eye. Here's the original drawing, and here it's been cleaned up a little bit for the book to make it look a little bit prettier. To the Galilean satellites of Jupiter. What's the significance of this discovery? It made Galileo even more suspicious that there was a problem with the geocentric model, because as you recall, in the geocentric model that Dr. Edelson told you about, all of the motions are ultimately centered on the Earth. Everything in the heavens is going around the Earth in one way or the other. Well, this observation of the moons of Jupiter immediately disproves that idea, because he could just see right here with his telescope that there were 4 stars, 4 satellites, which were actually going in orbits around another object, not the Earth. The Jupiter was at the center of this motion and not the Earth. So at this point, I would say Galileo was having more doubts than he had had before. He probably already had quite a few doubts about the geocentric model. He was taking seriously the idea of the heliocentric model, the possibility that the sun was really at the center of motion of everything in the solar system. And then finally, he hadn't really, I think, made up his mind very definitively in his book, The Starry Messenger, in 1610. What really iced it for him, what really convinced him that Copernicus was right and Ptolemy's system was wrong and had to be abandoned, was when he turned his telescope in 1611 to, for the first time he could see it when it had come around from behind the sun, to look at Venus. And he discovered and observed in some detail the phases of Venus. Museum of History of Science. And before we look at the fantastic collection of Galileo's instruments that are here, I thought it would be interesting to come into this room where one of the biggest and most impressive armillary spheres that I've ever seen has been assembled. This was made 5 years from 1588 to 1593. And it gives you an idea of what Galileo was up against. This is a kind of a toy model, which is also supposed to be very artistic, which shows the geocentric model of the universe according to, well, a simplified version according to Ptolemy. And the artist has visualized as a series of concentric spheres centered on the Earth. And it's a beautiful piece of craftsmanship. And there's one sphere here to show the motion of each of the planets that goes around the Earth, and also including the sun going around the Earth. And finally, the outer band here shows the fixed stars of the ecliptic plane of the zodiac. And as far as we can tell, this model may not really work exactly. I'm not sure it ever really worked exactly, but it's an incredible amount of workmanship to put it together. And it's kind of nice if you're a king or something, you just have this little model here, and there it is. It's the whole universe in your living room here. And so now I think maybe it'd be good to come in and have a little bit of a closer look here. And you can see, in fact, that they already had a fairly sophisticated globe of the planet Earth. We're looking at the inner workings of this armillary sphere, and you can see each one of the tracks for the planets. Obviously, this is not to scale, because the planets aren't all bunched up together like that. But for the artist to make it work, it was necessary to cram them all in together. And I believe that all of these spheres can rotate independently of each other, which is pretty hard to do mechanically. And what I hope you can see in the center there is their pretty good map on the globe that shows their knowledge of, you can even, it's North American continent, and you can see even the west coast there, which has been mapped a little bit. So people are already exploring the globe pretty extensively, still laboring under this incorrect model for the Earth's position in the solar system. And so there really was a lot of interested in astronomy right in the beginning of his career, before telescopes were invented. And before telescopes, people had built some very beautiful instruments that were related to observations of stars in the constellations called Astrolabes. This is one of the most beautiful, large astrolabes I've ever seen. This is one that Galileo actually used himself, and they're just fantastic precision pieces of art and function. And you can see, if you look more closely, that the positions of a number of bright stars in the constellations are indicated at the tips of these little wires. And then you can also see the entire line of the ecliptic, the constellations of the zodiac going around the sky. And so you can turn this around on this disc, this brass disc, to indicate any time of year and any hour of the night. That's what a lot of these lines are indicating, and this will show you where all of the stars could be. So this is helpful, of course, for things like navigating. And indirectly also it's related to timekeeping as well by the motions of the stars. So this was developed in a very fine art, in fact hundreds of years before Galileo came along, and he was very much in this tradition. So I thought this was neat to see since it's here in this Medici collection of Galileo's instruments.
Keep pressing the recording button.
No. The case that I really wanted to show you, these are the only surviving telescopes, or the original telescopes that Galileo put together to make his terribly important discovery observations. And it's really worth looking at these. This is the first one, because at the time it was very difficult for anybody to make a working telescope. And only a few people even had an idea of how to do it. And they were very primitive and very small and didn't have very much power. And so the first one actually only magnifies things by a factor of 3, which is fairly useful for a few astronomical observations. Then Galileo moved up to a 9 times magnification. He was continually trying to improve the telescope. He eventually got up to something like a 30-power telescope. It has a leather tube, I think, and this bottom one is a paper, or sort of cardboard tube. But one of the big problems that Galileo realized right away was that, first of all, he had to have perfectly polished lenses so that they wouldn't make a lot of distortion in the image that he was seeing and spread the colors out and make things very confusing. He also had to have these lenses aligned exactly so that he could get things to make a nice sharp focus. That was really a lot of the art here, and it was something that a lot of other people couldn't catch on to. So for a long time, Galileo was in a kind of unique, practically unique position in Italy of having one of the best instruments, and it was very difficult for other people to even, if they wanted to try to duplicate his work. People were very suspicious of views through telescopes. They were worried about optical illusions and getting tricked by the kinds of things that you might see, because it was not a familiar idea that you can look through a tube that will magnify something 3 or 10 times and then trust that what you're seeing is really right. It seems almost like a trick to people, and so some people would look with a great deal of suspicion. Some people wouldn't even look through Galileo's telescope at all. But anyway, these are the telescopes that allowed him to make those terribly important discoveries. And now we'll look in the other room where we have even a larger lens from a bigger telescope that doesn't survive today. It's like a little bit of a close-up zoom. Of Galileo's telescopes. One of the things that strikes me about it is I really like the little gold embossing on the tube. You know, that's to make it look artistic. It's impossible to imagine anybody putting little gold embossing embroideries and decorations on the Hubble Space Telescope, for example. But that's because Galileo lived in a different time when people did not think that art and science were completely separate endeavors. So that's a note to you art majors that they don't necessarily have to be completely separate fields, and certainly Galileo didn't think that they were completely separate fields. Now, the one down here is bigger and it's a little bit more worn out. Look, we're lucky to have anything surviving it here at all, but it's nice to see. So these telescopes, since Galileo finally he did get that job with the Medici. I was wrong when I was back at the library. It was a very smart move to call the Galilean satellites of Jupiter the Medici stars, because they came through in a big fat job to move him to Florence Florence, where he really wanted to be. As he wrote in one of his letters, he had doubled his salary. He had 3 times higher salary than anybody who had ever held a position before. And as far as I can tell, instead of giving lectures like he had to do in Padua and Pisa, the only thing he really had to do, aside from his own research in this job, was occasionally to show up at dinner parties for the Medici and talk about astronomy. Pretty cushy job, anyway. And so that's why now the Medici kept this priceless collection of Galileo's instruments up to the present day, where they've come to this museum. Beautiful collection of telescopes that were made after Galileo, but in the same century, in the 1600s. And you can see the gradual technological progression to bigger telescopes, more magnification, more power. And of course, it took quite a lot of skill to make these, and still these are a long way from what we had in later centuries, but people were able to see more and more of the sky. But I think really Galileo's discoveries were probably one of the primary impetuses to people wanting to build these beautiful, more powerful telescopes. And I'd say his impetus has not been exhausted. It's driven us to build the Hubble Space Telescope, and even the Keck telescope is a fairly direct descendant from his first starts. In that very fancy, it looks almost like a reliquary where you keep some of the remnants of a saint. You can see the surviving eye lens of one of Galileo's telescopes that I believe it was very well polished, quite accurately polished, even though it's now a little bit cracked. And even in his lifetime, he was becoming fairly famous or infamous. And afterwards, he became really quite a big star. And so that's why his little lens became so famous and got such a nice place to store it. And while we're at it, speaking of becoming famous, one of the things that happened to people who are really famous is when they get buried in the big church, they decided to pull out the body and cut off his third finger here and enshrine it right there. Hope that's not too ghoulish. Remember, in the 17th century, that was still the kind of thing to do, although we don't do that to astronomers today, unfortunately. Galileo had been interested in a lot of other things before he turned to astronomy and with the invention of the telescope. You might remember he was also interested in studying mechanics, the motion of bodies, and, for example, why things fall and why things are accelerating. In fact, Galileo really came up with a definition of a uniform acceleration. That is a constant change in velocity in a fixed amount of time. That is what a uniform acceleration is. And he realized that that is what objects experience when they're falling in the Earth's gravity. He didn't quite yet realize what exactly the force of Earth's gravity was, but he was measuring its effects, this uniform acceleration when you drop something. And to measure this accurately, one of the things he realized was very important was to time things while they were moving quite accurately. Remember, they didn't have stopwatches, they didn't have clocks in those days. He, in fact, spent a fair amount of time inventing new kinds of clocks that could measure time more accurately. And that helped with some of his experiments. Also, because things drop so fast when you drop them straight down, he came up with a different idea for measuring uniform accelerations, which is to roll things down on smooth inclined planes. They're, of course, accelerating due to gravity also, but the acceleration is much less because it's now on an incline instead of falling straight down. So you could actually measure the times more easily with this trick. And of course, one of the other things Galileo was very well aware of was the importance of eliminating all the sources of friction. No rolling friction, no air friction, because that would defeat the measurements. That was something the Greeks had consistently failed to take into account, the fact that a moving object does experience friction, that's the force that causes it to slow down. If there were no friction, then the object would continue moving, and in these forces of the gravitational field, it would continue to accelerate uniformly. And this is one of the most clever things, I think, that Galileo came up with. By the way, he had quite a lot of time to do this after he had sworn to never teach the Copernican doctrine anymore. Remember, after his trial at the hands of the Inquisition that sentenced him to house arrest, he had another 10 or so years to sit around in the house, aside from receiving experiments on mechanics. And so a lot of his work in other areas of physics, he really founded whole areas of physics. I believe that he made a microscope, for example. He was interested in measuring temperature, many other things. Anyway, a lot of this stuff was done when he basically retired under threat of torture. He retired from astronomy. Actually, that is an interesting system. We do have a problem with retirements in our department, but I guess we won't use that system. Anyway, so what this inclined plane is designed to do here is we have a channel where I can roll a ball smoothly down it, and as it passes each of these spots on the channel, it will give you a little bell ring, and of course your ear is very good at hearing things quite rapidly. Now, what you're supposed to notice here is, in this experiment, we have the bells lined up at approximately equal distances from each other. So the bell will ring when the ball has traveled equal intervals of distance. And of course, what you're supposed to notice is, because it is uniformly accelerating, the bell rings are going to start out fairly widely apart. And then as the ball continues to pick up speed, the bell rings are going to get closer and closer together, geometrically closer and closer together. So let's see if we can get that now. I'll start the ball rolling here. Listen to the spacing of the bells and then the final thwack when the ball hits at the end of the trail. And I think you'll notice that they're getting closer and closer together. This is the illustration that Galileo used. By the way, that is, I think, a pretty famous fresco painting where he is showing this demonstration that you're about to see to some real big shots, some popes and cardinals and so on, I think in Rome, where he was always trying to push his theories. He really believed that he could single-handedly win over the entire Catholic establishment to his way of thinking and convince them, which was a little bit overly ambitious, as it turned out. But anyway, here's the demo. Here it goes. So listen for the bells. I'm going to run it one more time, but what I want you to think about, and I'm going to ask you this when I come back, I guarantee I'm going to ask you this on Tuesday, is how, and I've got a video actually that shows this, how would you have to move the positions of these little bell gates? You see they're movable, you can set them up any way you want. How would you have to set up these gates if you wanted to make the rings of the bell be spaced uniformly in time? So you have 5 rings and then a thud at the end. It would just go bing, 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 thwack. That's not what you're going to hear here. But you tell me how you could space these things out along the railing in order to produce that effect instead of this one. Anyway, just to catch it again and just so you can tell the difference, here's what happens when they're uniformly spaced. The bell rings get closer and closer together with time, higher and higher frequency as it gets down to the bottom. And finally, it hits the end of the railing quite quickly after the last bell. And here it goes. Go.